Okay, in the previous lesson, we were learning about polynomials. We learned that there are different types of polynomials. We had examples of monomials, binomials, and trinomials. And then we also learned that we can take polynomials and add and subtract them together. Today, we're going to look at a third operation, and we're going to multiply some polynomials together, specifically by a monomial. The first example here I want to look at is negative 3x squared times 7x squared minus x plus 4. The negative 3x squared on the outside, that's my monomial, my one term, and I'm going to multiply it by a trinomial in the parentheses. Now, whenever we had grouping symbols, we're taught that we're going to use the distributive property, so we're going to use that again with variables. Now, I'm going to distribute 3 different times, and I'm going to signify that with 3 different colors. So the first color I'm going to use is red, and that says negative 3x squared times 7x squared. That's my product for the first distributive property. The second one in green, negative 3x squared times negative x. The third one in blue, negative 3x squared times 4. Other properties that we have learned in the past is the commutative property. And what the commutative property stated was that order doesn't matter when you multiply. Which that is nice here, so I can take what I have in each of my products. I can have in red, what I have in green, and what I have in blue, and I can reorder them up with my variables and my numbers. So I'm going to reorder these. Negative 3 times 7 times x squared times x squared. In green will turn into negative 3 times negative 1 times x squared times x. And then in blue, negative 3 times 4 times x squared. The next rule that we've learned in the last chapter is that our product of power rule. That if we had the same base, we can take the exponents from those bases so we can add them up. So if I look what I have in red, my like base is the x. So that means I can take my second power for the first x and my second power for the second x, and I can add them up to give us 4. And then I'm also going to multiply negative 3 times 7 to get negative 21. So that simplified will give us negative 21 x to the 4th power. Then I look at green. My first x, my exponent is a 2. My second x, my exponent is a 1. 2 plus 1 will give us 3, so that would be my new exponent for that x. And then again, I'll multiply negative 3 and negative 1 to give us positive 3. And finally, with the x that I have there, I have a second power, but I do not have another x that I can look at to add exponents. So I will keep that x squared, multiply the negative 3 and the 4 to get negative 12. So I have negative 12x squared. So the final answer here for this product, negative 21x to the 4th plus 3x cubed minus 12x squared. Here's another example. So my monomial on the outside, 6d to the 3rd power, now is going to be distributed through a 4-term polynomial. So I've got 4 different distributive properties, and I'm going to go ahead and do some of these other properties along with it to rearrange it so it doesn't take up as much space. Second distributive property, third distributive property, and finally the 4th one. Now that I've got each one broke down, then I can go ahead and simplify with the 6 times 3 to give us 18. D cubed and d to the 4th will turn into d to the 7th power. Then we look at negative 2 times 6 to give us negative 12. D cubed and d cubed. 3 plus 3 is 6, so that'll be my new exponent for d. Negative 1 times 6 will give us negative 6. Then I have d cubed and a d, so that will give us d to the 4th power. And then finally, 6 times 9, 54. I don't have any other d's to add with the 3rd power, so I will leave it d to the 3rd power. So final answer for this example, 18d to the 7th minus 12d to the 6th minus 6d to the 4th plus 54d cubed. Now what happens when you get an example where I've got 2 sets of parentheses? Well, I need to remove all grouping symbols that occur in the problem. So I'm going to look at the first parentheses. I'm going to get rid of it first. 2p times negative 4p squared. And since we have a better understanding of what's going to happen when we multiply through the distributive property, I'm going to go ahead and simplify the distributive property. So 2p times negative 4p squared will give us negative 8p to the 3rd. The second time, 2p times 5p will give us positive 10p squared. Then I'm going to get rid of the second parenthesis. Now you have to be careful here because there is a negative sign in front of that 5, so I'm actually distributing negative 5 through this parenthesis. Negative 5 times 2p squared will give us negative 10p squared, and then negative 5 times 20 give us negative 100. Now once you start getting rid of multiple grouping symbols, you do have to be aware of like terms. So the next thing is I need to combine any like terms if there happen to be any. Now if I look right in the middle here, I have a positive 10p squared and a negative 10p squared. They both have the same variable with the same exponents. So those are like terms. A positive 10, take away a 10, we'll cancel those out. So my final answer will be negative 8p cubed minus 100. Of course, you might get examples that have more than one variable in them. So how would you do these? Well, if you look out front of the first parentheses, see how the variable is a t. So when I go through and distribute through this, I can only add the exponents for the same variable. So I got t to the 5th and a t. Those are the ones that I'm allowed to add the exponents with. The y's are not the same letter as t, so I will not add their exponents. So when I distribute the first one, 15 times 10 is 150, but I will leave it y to the 3rd since y is not the same letter as t. T and t to the 5th will turn into t to the 6th. Distribute the second time, 15 times 5 gives us 75. Again, y squared is going to stay y squared because y is not the same letter as t, but t and t makes t squared. Move over to the second parentheses. This time I've got a letter y out in front, so when I distribute, I am going to be adding the exponents for the variables that are y. So first distributive property, negative 2y times yt squared will turn into negative 2y squared t squared. And again, I kept t squared the same this time because it's not the same letter as y. Distribute a second time. Negative 2y times 4y squared will give us negative 8y to the 3rd. And then just like the last example, I need to combine any like terms if possible. Now like terms are letters. They have to have the same letters, and those letters have to have the same exponent. So if I look in the middle, I have y squareds and t squareds. They both have the same letters, and they both have the same exponents. So then I'm going to take 75, take away 2, and that'll give us a final answer of 150y cubed t to the 6th power plus 73y squared t squared minus 8y cubed. The last thing that we're going to do is we're going to put all this back together. We're going to solve equations out of this. So every grouping symbol that I have that occurs, I have to get rid of. There is 1, 2, 3, 4 parentheses, so I will distribute 4 different times. So the first parentheses, 2a times 5a will give us 10a to the 2nd. 2a times negative 2, negative 4a. Look at the second parentheses. 3a times 2a will give us positive 6a squared. 3a times 6 will give us plus 18a. And there is a plus 8 that's out there that I'm not able to distribute, so I'm just going to carry that down and leave it with that left side of the equation. And I'm going to move over to the right side. A times 4a will give us 4a squared. A times positive 1 will give us positive a. Go to the fourth and final parentheses. 2a times 6a will give us plus 12a squared. 2a times negative 4 will give us negative 8a. And just like the 8 on the left side, I've got a 50 on the right side that I was not able to distribute, so I'm going to carry that down and leave it as part of the right side of the equation. Now, I've made the analogy in the past that when you solve equations, it's kind of like making an essay for your English class. You have a rough draft, and then you want to edit that rough draft to get it down to your final draft. Well, here's what I have for a rough draft. I need to edit this thing. I need to combine my like terms on the left side and the right side separately. Let's focus on the left side first. I've got 10a squared, and there's also a 6a squared. I'm going to combine those up and make it 16a squared. I also have negative 4a and positive 18a. Those are like terms, and I'm going to combine those to give us 14a. Again, the 8 didn't have any like terms on the left side, so I'm going to bring that down and leave it with the left side. I'll move over to the right side. 4a squared and 12a squared are like terms, so I'm going to add those together and get 16a squared. I have a and negative a, 8a. I'm going to combine those together to give us negative 7a. And the 50, no like terms yet, so I'm going to leave that with the right side. So I'm getting closer to solving this thing for a. I want to try to get my like terms on the same side of the equation. So the first thing I'm going to do is I'm going to subtract 16a squared from both sides. But what you'll notice with those 16a squareds is that they cancel out. Now I want to get the a's together. Now if I do an I test, if I subtract 14a over to the right side, my a's are going to be negatives, and I'd like to have positives if at all possible. So instead, I'm going to add 7a to both sides. Simplify to get 21a plus 8 equals 50. Then I'll subtract 8 over. Once I subtract 8, I'll have an equation that says 21a equals 42. And then finally, divide both sides by 21, and I've got an answer that says a equals 2. So there's multiplying polynomials by a monomial and using that to solve equations.